Welcome back. So far, we've explored how computing evolved from traditional software to intelligent AI systems. Now we are going to answer one of the most common questions people ask. What's the difference between artificial intelligence, generative AI, large language models, and agentic AI? These terms are often used interchangeably, but they actually describe different technologies. By the end of this lesson, you'll clearly understand how they relate to one another. Think of artificial intelligence as a large umbrella. Everything we call AI fits somewhere underneath this umbrella. Artificial intelligence is the broad scientific field focused on building machines capable of performing tasks that normally require human intelligence. These tasks include recognizing images, understanding language, making predictions, planning actions, solving problems, and learning from experience. Not every AI system does all of these things. Different branches specialize in different capabilities. A useful analogy is transportation. Transportation is the category. Cars, trains, ships, and airplanes are different ways of moving people. Artificial intelligence works exactly the same way. AI is the category. Machine learning, computer vision, and generative AI are different branches of AI designed for different purposes. Machine learning changed how software is built. Instead of writing every rule manually, developers train computers using large amounts of data. For example, rather than programming thousands of rules that describe spam emails, we show the computer millions of examples. The system learns patterns on its own. This shift from explicit programming to learning from data is one of the biggest milestones in AI. As computing power increased, researchers developed a more powerful form of machine learning called deep learning. Deep learning uses mathematical structures known as neural networks. Although inspired by biological neurons, these are not digital brains, they are networks of mathematical functions that learn increasingly complex patterns from data. Large language models are built using deep neural networks. Natural language processing, or NLP, focuses on helping computers understand human language. Language is surprisingly complex. Consider the sentence, I went to the bank. Does bank mean a financial institution or the side of a river? Humans resolve ambiguity naturally. Teaching computers to do the same has taken decades of research. Modern language models have dramatically improved this capability. Generative AI is everywhere, but what makes it fundamentally different from the AI systems we've used for years? Traditional AI was strictly predictive, built to make decisions, not to create. Feed it a photo, it identifies the visual patterns and outputs a single decision. Cat, but ask that system to paint a completely new picture of a cat and it fails. Predictive models can only categorize existing data. They cannot synthesize something original. To actually create, the architecture has to change. The network expands into a massive mathematical structure, adding dozens of hidden layers that learn incredibly complex patterns. This is deep learning. Now watch the generative mechanism work. You type a simple text prompt, and those deep hidden layers run your words through millions of established pathways. Instead of making a decision, it constructs an entirely new original image from scratch. And this architecture scales. The exact same deep learning structure synthesizes text, software code, and music. So the next time you see an AI generate a working app or compose a full song, that's this exact deep learning process at work, reshaping entire industries from a single text prompt. You may already be using generative AI. ChatGPT generates text, GitHub Copilot writes code, Midjourney creates artwork. Runway generates videos. Although these tools create different types of content, they all belong to the family of generative AI. Large language models, often called LLMs, are one specific type of generative AI. They specialize in understanding and generating human language. When you ask ChatGPT a question, It doesn't search for a stored answer. Instead, it predicts one token at a time until it generates a complete response. We'll explore this process in detail in Module 2. Here's one of the most important ideas in this course. A large language model is not an AI agent. An LLM generates responses. An AI agent pursues goals. Suppose you ask an LLM, write an email inviting participants to a workshop. It writes the email, its job is complete. Now imagine asking an AI agent, organize next month's workshop. The agent can plan tasks, send emails, schedule meetings, update calendars, monitor registrations, and adapt as new information becomes available. That difference defines agentic AI. Let's summarize everything we've learned. Artificial intelligence is the broad scientific field. Machine learning is one way of building AI. Deep learning powers today's large language models. Generative AI creates content. Agentic AI combines large language models with reasoning, planning, memory, and external tools to achieve objectives. Think of it this way: generative AI answers questions, agentic AI accomplishes goals. Imagine a customer submits a complaint. A generative AI system drafts a professional response. An agentic AI system goes much further. It retrieves the customer's order, checks inventory, processes a refund if appropriate, updates the CRM, notifies the logistics team, and follows up with the customer. Instead of generating information, it completes the workflow. This shift from content generation to autonomous task execution is why agentic AI is becoming the next frontier in enterprise AI. Let's recap. Artificial intelligence is the broad field of creating intelligent systems. Machine learning enables systems to learn from data. Deep learning powers modern AI breakthroughs. Generative AI creates new content. Large language models generate human language. Agentic AI builds on these capabilities by adding planning, reasoning, memory, and tool use to achieve goals autonomously. In the next lesson, we'll explore why agentic AI is considered one of the most transformative technologies of our time and what it means for businesses, governments, educators, and society. Thank you for joining me, and I'll see you in the next lesson.